So in a nutshell, what does the Magic Box do? Well, it allows me to monitor the HF bands using my SDR air spy. So that gives me a pan adapter or a waterfall. So that's a way of searching the band and makes my life a lot easier, but still lets me use my really basic QRP gear. We've also got a detection of transmit on here that disconnects the antenna to the SDR, and some protection that's installed in this with back-to-back diodes so we don't overload the input to our SDR. Over here, we have a choice of 6 antennas selected very easily via this switch. Now, if I want to disable the transmit disconnect, we can flip that down and that earths the antenna to the SDR. Normally going to leave that on. Over here, we have a 6 possible rigs that we can plug in. At the moment, I'm only using, I think 4 of them. That gives me a little bit of scope for expansion later on, and I can leave the cables labeled 1 to 6 on the bench here, and so I'll have 6 different zones, so I can line up QRP rigs and operate them within a given zone. So that allows me to change between the different zones, and this is just a sensitivity on that transmit sensing on the SDR. Having a heap of fun with this. It is so much more convenient, and I'm just working on ways to make this station more and more user-friendly, and also more knobs, more buttons, more switches, and more things that go click, 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 flash, 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 because that's what I like. Hi, and welcome to another episode of The Art of Engineering. In today's episode, we're going to look at my Magic Box project. Anyone that's been watching the videos on this channel might or might not know that I like to build a lot of QRP rigs, not a lot so far, but a few, and usually monoband rigs. So at any given time, I could be wanting to operate my 80 meter rig, or my 40 meter rig, or the QDX from QRP Labs. What a fantastic G-modes transceiver that is. And also quite often listening on my AirSpy Discovery because it's got a lovely waterfall so I can see what's going on. But it's been very frustrating of late because quite often I'll see a signal on the AirSpy and I'll think, quick, jump over on 40 meters and grab that CQ call, but by the time I've juggled cables and whatnot, the call's ended or someone else has gotten in, or worse still, I select the wrong antenna and I risk blowing the final stages in the rig. So my current arrangement served me reasonably well, and certainly better than what I started with, but it was time to make a change and make the station more efficient. People that watch my channel will probably know about what this is, and it's my antenna organizer. So on the left we have the antennas, the inverted V, the vertical L, my UHF, VHF prepper antenna, all videos on that. Over here we've got the rigs on this side, so 80 meters, 40 meters, the TS520, the AirSpy, the QDX, and my ATU when I had my L-match in there. And what I would do is I would use the power SWR meter as the hub. So we'd plug the antenna in the top and the rig in the bottom here, and off we would go. And look, it served me okay, but I've always been worried about this plugging and unplugging. It's not the best thing to be doing to connectors, and eventually mechanically they're probably going to fail. So anyway, we found ourselves on Alibaba and his 40 Thieves Express, and we bought ourselves 2 of these antenna switches. They're remote antenna switches that have 6 positions. I think they're designed to actually switch antennas from a remote location. But I looked at the specs for them. They don't look too bad. Certainly for HF, they should be good enough. So this is what I'm going to use to create my Magic antenna box. So here, folks, is my dastardly plan. At the moment, I've got my new Kenwood ATU, and it's got options for a number of antenna inputs, which is great. It's also got a dummy load output. So I will be, at some point in time, producing a dummy load for the ATU. That'll be in an upcoming video. But at the moment, what I'm planning on doing is I've ordered 2 switch units, relay switch units. They're remote antenna units. So what I'm going to do is I'm going to have an option for 6 rigs on this one, and I'm going to have an option for 6 antennas on this one. So the rigs will go to the input of the ATU, And the antenna options, all 6 of them, will be fed into the antenna input on the ATU, on antenna number 1, okay, because there's about 3 antennas on the back of that ATU. So I'll have antenna 1 selected, which means that I can go on the through connection on the ATU, which means it'll go straight to the antenna. So the rig will go straight to the antenna via the ATU. So the ATU is like a hub. If I need to tweak the antenna, I can go to match on the actual ATU on antenna 1, and I'll be able to tweak it if it's not resonant or if it's in the section of the band that isn't resonant. If I'm using the TS520, I'm going to need a high power dummy load if I know that the antenna is not resonant. So I can tune up the actual Pi network in the transmitter for the tubes so I don't blow my tubes, and then I jump onto the antenna and fix that up. Okay, folks, this is our switching unit number 2. We'll just get the lights off and see if you can see this. 1, 2, 3, 4, 5, 6. 6 relays, all switched on the 13.8 volt supply. And we have a 13.8 volt supply. Shut up. We have a 13.8 volt supply, and I'll show you that now. And that's quite an interesting supply as well. So you might want to watch that video. Here is the absolute love of my life, my steampunk 20 amp supply made with 2 rewound microwave transformers to give me 20 amps based on Drew Diamond VK3XU's design from Projects for the Radio Amateur. And it is a thing to behold, and thus far been a wonderful workhorse powering my shack. Oh, it's like Christmas time. Well, we have marked out the holes that need to be drilled in this unit, and it never ceases to amaze me just how much metal work needs to be done preparing a case. Front and back, we've marked it out so that we know where all the connectors and all the LEDs and whatnot are going to go. I will drill small holes in each of those as a pilot hole, and then we'll drill up to the size that's required. Hi folks, a bit of a progress report. It's a beautiful Tuesday afternoon, and we are back working on the Magic antenna box. And all the drilling is done. So that is all the connectors that will go on the back, and that is the front. And I'll just grab the camera and I'll show you kind of how it's going to be laid out on the inside. And this is what the inside of the Magic box will look like. We have the rig and antenna switching, and in the middle here I'm going to be building a circuit that will switch the loop on the ground antenna to earth when it detects transmit. Now this circuit will be only useful for the HF frequencies. It will have inherent capacitances and whatnot that will make it pretty much useless on VHF, UHF. So as an SDR switch, it's going to be designed for HF, which is what I need it for. And yeah, SDR loop on the ground will come in, it'll go through here and then out again, and somewhere on here I'll have a little toroid that detects transmit that will earth the antenna when I'm on transmit so we don't blast the input to the SDR. And I'll also have some back-to-back diodes on this as well to protect against putting too much RF into the front end of my SDR. So happy days. I'm having a great old time home brewing. It's nearly time to go to bed. We have all the LED holders and some of the LEDs in. That's the rig selection side. And so that is kind of how the whole thing is going to look from the front. And I'll just show you the back as well. That is the back of the Magic box. We have our earth, power. This is rig input. There the rigs coming in. We'll have our SDR going through, and that will be connected to a dedicated receive antenna. Maybe a loop on the ground. We're going to try that, and maybe a few other dedicated receive antennas as well. Fortunately, we don't have enough space here for a beverage. And these are the antennas that will come in here. So we'll have a choice of 6 antennas that will run off to the ATU antenna socket. This will run off to the ATU rig socket, so that will be our SWR meter happening, and that ATU also has a dummy load position, so I'll be able to switch to a dummy load should I need to. And that is the other unit that needs to go in, and that's ready to go. So all we need to do is attach our coax leads to that. I may tidy that up a little bit with a few cable ties. It is a bit of a rat's nest, but we have tried it. We've continuity tested it and whatnot, and it all looks like it is right. Okay, and this is my SDR timing circuit. At the moment, we haven't got the detector circuit on it, but we're going to detect transmit via a toroid that slipped over one of the transmit lines in my magic box, and that will fire off a FET, which is being emulated by this push button switch at the moment. So when we hit transmit, that is the relay closing. I'm using my meter on continuity test, so you can hear the meter going off because the relay is earthing the antenna. Hi there. Now, I was expecting a huge amount of problems with this circuit because, well, it's a circuit that I've developed, so I'm expecting problems whenever I'm doing that, because the thing they say about a little bit of knowledge is that a little bit of knowledge can get you in a lot of trouble. So what I've done here is I have put in a FET transistor. Now, I don't know how this responds to higher frequencies. I don't know whether it's going to behave at higher amounts of power. I do know that I am going to put a switch on this isolation circuit, and also that the through part of my magic box is only going to be for receive only. So there's no chance of actually transmitting into the actual SDR. I've put back-to-back protection diodes on that line as well, so even if there's high amounts of RF induced in it, they'll be clipped. I've also made sure that I've put a switch on it so that I can switch off the power to this switching circuit, and also when I do that, whenever I turn off the power to this circuit, it will ground the antenna. So in a power off condition, the actual antenna will be isolated from any RF that may be induced in it. Anyway, talking. What I ended up doing was I was still finding that it was chattering the relay unless I set a really long delay, in which case when I go to the end of my over, if I do want to use the SDR to receive, it's going to be too long a delay and I'm going to miss the first part of the returning message. So what I've done is on this board here, I've put a in the actual gate circuit, I've put in a capacitor. I think it's 22 microfarad, and then across that capacitor, I originally had the delay happening here. Now I've short-circuited the delay on this circuit, and I'm delaying via that SCR. And I think what's happening is that I'm adjusting the time constant such that the sensitivity can be adjusted via this potentiometer. Anyway, I'll show you how it works. When I hit transmit, the light comes on, and you can hear that beep. The beep is the closing of the relay, because I'm using the meter to indicate whether the relay is on or off. So that is how that works. But if I'm transmitting constantly, you can hear that it's not. And then when I stop, relay opens. So I am amazed that it's working as well as it's working. I may get my Oz QRP and plug that in and just see how well it works on voice using about 5 watts and on 7 meg. So we'll have tried it on, this is 3.5 megahertz because it's my 80 meter transmitter. We'll try it on the 7 meg. They're the only 2 QRP transmitters I've got at the moment. How it works on higher frequencies will be a mystery to be solved at a later date. Okay, we've got the Oz QRP at 7 megahertz. CW, the relay does open and close a little bit. I don't think it's going to be a problem. Like I said, we're not actually transmitting into the same antenna. It's on a through line that's a dedicated receive antenna, and it is activating, but it's activating. We shall see how it operates when it's put into play as a receive-only situation, but I've got it on double sideband now, and you can have a look at how it works. Now, while I'm speaking, if you can hear the actual relay close, which means this multimeter will be screaming away, you'll know that the antenna has been earthed on the SDR, and you won't be hearing loud amounts of noise. And like I said, I have protection diodes on it. Now, I know what everyone's thinking. This is going to be woeful for the SDR when you're using it on VHF, UHF. That is 100% correct. This is a system that I'm building to play with HF and use this as a pan adapter on HF. I'm not going into the black arts of VHF operation. So let's see how it goes with double sideband. Hello CQ, hello CQ, hello CQ, 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 CQ. This is Victor Kilo 2 Alpha Oscar Echo testing 1, 2, 3 into dummy load on 7 megahertz. And there you have it. Let's see how it works on CW. Mic down, CW gain up. That's my old call sign. The relay is chattering coming on and off. So not as good as it was on 80 meters. I'm suspecting as you go up in frequency, there's going to be issues with it. Hey, everything I do is an experiment. I'm happy with it, and I'm going to wire it up and chuck it in the box. I have decided that this sensitivity control I will have coming out of the front of the unit, because I'm thinking access to that might be very useful down the track when I'm trying to play with it on higher frequencies. Well, Heidi Hody, we just spent a good deal of time labeling. Now these actually should have a clear sort of layer of varnish over them, but hey, we've got the whole thing assembled, so that's as good as it's going to get. So I'm just going to be careful. They're probably going to come off at some point in time, but everything's labeled, so I know where it all is. And we are raring to go. But before we start trying to plug the thing in, I do need some shorter patch cables, and in the past when I've crimped these, I've done a really bad job of it, but hey, nothing ventured, nothing gained. So I'm going to get the crimping tool out again and give it a crack. That's one end done. It's helpful to have the correct tool. Unfortunately, the connectors I've got, or the crimping tool that I've got, doesn't crimp the center conductor very well on these, but I've had to solder instead, and we're going to use a bit of heat shrink on the end there as well. Just to make the end of it nice and tidy. So it takes a bit of the strain off as well. And hey, we've got the heat shrink, so why not use it? I'm just hoping when I get this whole connector done that there's no shorts and it's all looking like it should. But that's one end. Plenty of videos online how to do this. I'm not going to show you how to do this, but just look up crimping B and C connectors onto RG58 and you'll find a billion different videos. But biggest problem is getting the right crimping tool for the right cable and getting the right connector for the right cable. There's RG58 different flavors. Some have a solid center conductor, some have stranded conductor, etc., etc. So I've never managed to get it correct, but I always manage to muddle my way through to something that works. Yippee-ki-yay! We have our first one done, and I think they're all right, but I'll meter them and make sure. This is the utter and total chaos that ensues when I start home brewing. But from the chaos will emerge, hopefully, success. So there it is, folks. It's time to install. We've got our patch cables done. Just make sure this microphone's on. Yes, it is. So it's time to plug all of this in and get it going.
V, number 2 will be vertical L, number 3 will be, let's make it V. Should be able to, but yeah. Okay. Goes to number 3, and the TS520 goes to number 4. And all this goes back up now. Obviously I'm going to have to do a bit of cable straightening out at some point in time. Well, that's not going to happen.
So we are plugged in and almost ready to go. Hi, well now is the time I get to actually show you how the Magic Box works and how it's going to make my life in the shack so much more convenient. Now, I wish I had recorded it, but I've just finished installing my loop on the ground antenna video to come. And I heard a signal on the 40-meter band. It was quite an interesting signal. It had a little bit of a warble to it. It wasn't an unpleasant tone, but it didn't sound like a modern rig. And so I jumped down on the OzQRP after finding the signal over here, and we proceeded to have a QSO with Andrew in Adelaide. And the signal on the OzQRP was okay, but noise floor was quite high. But with the loop on the ground antenna implemented and the AirSpy Discovery used as a receiver, the QSO happened so much more easily. And this is Andrew's QRZ page, or a photo that appears on the QRZ page. And as you can see here, he has some amazing old Army gear. I think some of it's aircraft as well. Let's jump down on 7 megs and I'll show you how that works. This is Victor Kilo 1 Charlie Tango working Victor Kilo 2 Tango Mike. This is the loop on the ground, and this is what it sounds like on the OzQRP. And I'll just swap the antennas over and show you what it looks like on the end-fed through the SDR, same radio. I'm going to switch over to the antenna that I've got next to the SDR, which is on the number 5. Number 1 over here, this is the vertical, that's the end-fed halfway. So if I swap the antenna outlets over here now and unmute, you'll be able to hear what this sounds like on the end-fed halfway. So that is the end-fed half wave, and this is the loop on the ground. Well, thanks for sticking around right to the end of the video. I have had so much fun playing around with this magic box. Tonight I came home from school and we fired up the OzQRP and I worked Adelaide on the loop on the ground, listening on the loop on the ground, transmitting on the end-fed half wave. And I also just did an 80-meter contact on SSB using the TS520 through the magic box and listening to the loop on the ground. Interesting thing was that the loop on the ground worked really well for the VK5 station and was pretty woeful for the VK2 station. And then listening on the TS520 for the VK2 station was better. It's a bit of a mixed bag, I think. Stick around because coming up on the channel, I'm going to have a video on that loop on the ground, and we're going to really dig deep and do a few QSOs and have a look at how it performs. And then think about maybe some other flavors of receive-only antennas, because that seems to be the next rabbit hole we're going to go down. Anyway, 7-3, and I shall see you in the next episode of The Art of Engineering.